The objective of the Marshall stability test is to determine the optimum bitumen content in bituminous mix that provides the best combination of stability, flow, and volumetric properties for flexible pavement construction. Specifically, the test aims to, the first one is evaluate the maximum load carrying capacity, which is Marshall stability of the bituminous mix. And the second one is measure deformation flow value of the mix under loading condition. And the third one is assess the effect of varying bitumen content on the strength and flexibility of the alpha mixture. The fourth one is determine the optimal bitumen content, which is OBC, that meets the required specification for pavement performance. And the last one is ensure that the mix design has adequate durability, density, and resistance to deformation and cracking under traffic loads. Assalamualaikum. Hi, my name is Muhammad Zaiputra Zulkafli. My matrix number is 17DKA24F1038. So for the theory, the Marshall stability test is a standard laboratory procedure used to design and evaluate bituminous mix for flexible pavement structure. Developed by Bruce Marshall in the 1913, the method is widely adopted due to its simplicity and effectiveness in optimizing the asphalt mixture for stretch and durability under traffic loads. The test primarily assesses the load, varying capacity, and deformability of a compacted bitumen aggregate mix when subject to control condition. In this test, cylindrical specimens are prepared by mixing heat aggregate with varying percentage of bitumen and compact using a standard number of hammer blows, usually around 75. These specimens are then immersed in a water bed at 60 Celsius for 30 to 40 minutes to simulate field temperature condition. After conditioning, each specimen is placed in a Marshall testing machine which applies a compressive load at a deformation rate of 50.8 mm per minute until failure. I will continue about the second theory. Is two key values are recorded during the test. For the first one is Marshall stability, the maximum loads the specimen can sustain before breaking, and the second one is flow value, the total deformation in millimeters of the specimen at the point of maximum load. In addition to these two parameters, volumetric properties such as air voids, voids in mineral aggregate, and voids filled with bitumen are calculated to ensure the mix has proper density, durability, and resistance to deformation or cracking. The optimal bitumen content is selected based on the mix that provides. And for the maximum stability, acceptable flow, air voids in the range of 3 to 5%, adequate VMA typically around 13%, and for VFB is 65 to 75%. A mix with insufficient bitumen may be strong but brittle, while excess bitumen can cause deformation or rotting. Thus, the Marshall method balances both stiffness and flexibility of the pavement.
Assalamualaikum to everyone. My name is Haris Daniel bin Aris Fazila. My matrix number is 17DKA24F1044. And today I'm going to introduce about sample table, bitumen content versus stability and flow. And for the table is we got bitumen content, Marshall stability, and flow. First is bitumen content. That is 4.0, 4.5, 5.0, 5.5, and 6.0. For the Marshall stability, 7.5, 8.9, 10.2, 9.7, 8.5, and next is flow, 2.5, 3.0, 3.8, and 4.2, and last one is 4.8. This table illustrates how stability increases with bitumen content up to a certain point, usually around 5.0%, after which it begins to decrease while flow continues to rise. The optimum bitumen content is typically selected at the peak stability value with acceptable flow and void parameters. Next is apparatus. First one is Marshall Mold, 4-inch diameter and 2.5-inch height. Next is compaction hammer, weight 4.5 kg, 457mm drop. And next is loading machine with proving ring and dial gauge. And last one is stability and flow meter, 4-inch diameter and 2.5-inch in height. Last one for apparatus is water bath, maintained at 60 Celsius. Oven for heating mix, balance sensitivity to 0.1 gram. Bitumen and aggregate for 4-inch diameter and 2.5-inch height. That's all for me. Thank you.
Hi guys, my name is Ishakim Ibirushgan with number registration
For bulk mixture preparation, measure
70DK241.
the amount of
And
aggregate and
today
filler
I
to be used in
will
order to
explain
meet the
about
specification
procedure
limit.
of Marshall
About
stability test.
1,200 grams of blended aggregate,
For bulk
sand
mixture
and filler, is
preparation,
prepared in a
measure the
container to
amount of
produce a Marshall
aggregate
specimen.
and filler to be used in order to meet the specification limit. About 1,200 grams of blended aggregate sand and filler is prepared in a container to
Oven dry
produce
the
a
aggregate at
Marshall
150
specimen.
degrees Celsius for at least 4 hours.
Oven dry the aggregate at
Heat the asphalt at the same
115
temperature, or a mixing temperature, which is about
Celsius
140 degrees
for at
Celsius.
least 4 hours.
Place the heated aggregate
Heat
into
the
the
asphalt
mixer and blend dry for 1 to 2
Heat the
minutes.
asphalt at the same temperature or at mixing temperature, which is about 114 Celsius. Add appropriate amount of asphalt based on the percentage of total mix
Add
weight
appropriate amount of asphalt, based on the percentage of total
and
mix weight,
continue the
and
mixing
continue the mixing
process.
process.
Before compaction, ensure the ready bulk mix temperature for compaction is equal or more than 137 Celsius. The mold, scoop, and spatula must be preheated as well. Use scoop to transfer the asphalt mix into the mold. Next, use the heated spatula to roll the mix vigorously 15 times around the perimeter of the mold and 5 times over the interior. This
Before
process
compaction,
ensures
ensure the ready
a
bulk mix
smoother
temperature for compaction
specimen
is equal,
and
or more
eliminate
than
any
137 degrees Celsius. The mold,
bridging of
scoop and
the
spatula
rock.
must be preheated as well.
Next, compact the mix carefully using the Marshall compactor for the proper number of blows as specified
Use the
in the
scoop to
mix
transfer
design.
the asphalt mix into the mold.
Reverse and reassemble the mold and apply the same number of blows to the face of the reverse asphalt mix. Use an extruder to remove each specimen by jetting the specimen up through the hole, keeping the specimen as perpendicular as possible
Next,
so that
use the
the
heated
specimen
spatula to ride the mix
isn't
vigorously 15 times around the
distorted.
perimeter of the mold, and 5 times over the interior.
Measure the
This
specimen height
process ensures
and
a
weight
smoother specimen and eliminate any bridging of the rock.
air and water. Heat the specimens in a water bath to a temperature of 16 Celsius for 13 to 14 minutes. Place the specimen in the Marshall testing rig. Load the specimen ratially at a constant of strain of 15.8 mm per minute. A trace relating strength and deformation is automatically recorded on a graph paper. Determine the stability of each specimen as the maximum load that the specimen could withstand. Apply correction to the stability values if required. Hi guys, my
Reverse
name
and
is Ishakim
reassemble the ball,
Ibrahim,
and
with
apply the
number
same number of
registration
blows to the face of the reversed asphalt mix.
17DK241. Again, today I will explain about the procedure of Marshall stability test. Okay. For bulk mixture preparation, measure the amount of aggregate and filler to be used in order to meet the specification limit. About 1,200 grams of blended aggregate sand and filler is prepared in a container to produce a Marshall specimen. Oven dry the aggregate at
Use an extruder to remove each specimen by
115
jacking the specimen up through the hole,
Celsius
keeping the specimen as
Celsius
perpendicular as possible
for at
so that
least
the
4
specimen is not
hours.
distorted.
Heat the asphalt at the same temperature or at mixing temperature, which is about 114 Celsius.
Measure the specimen
Add
height and weigh it
appropriate
in air and water.
amount of asphalt
Determine the
based on
specimen
the
density.
percentage of total mixed weight and continue the mixing process. Before compaction, ensure the ready bulk mix temperature for compaction is equal or more than 137 Celsius. The mold, scoop, and spatula must be preheated as well. Use scoop to transfer the asphalt mix into the mold. Next, use the heated spatula to roll the mix vigorously 15 times around the perimeter of the mold and 5 times over the interior. This process ensures a smoother specimen and eliminates any bridging of the rock. Next, compact the mix carefully using the Marshall compactor for the proper number of blows as specified
Heat the
in the mix
specimen in a
design.
water bath to a temperature of
Reverse
60 degrees
and
Celsius
reassemble
for 30 to
the
40
mold and
minutes.
apply the same number of blows to the face of the reverse asphalt mix.
Place the specimen in the
Use
Marshall testing rig.
an extruder to remove each specimen by taking the specimen up through the hole, keeping the specimen as perpendicular as possible so that the specimen isn't distorted. Measure the specimen height and weight in it in air and water. Heat the specimens in a
Load the
water bath
specimen
to
racially at a
a
constant rate
temperature
of
of
strain of
16
50.8 millimeters per minute.
Celsius for 13 to 14 minutes. Place the specimen in the Marshall testing rig. Load the specimen racially at a constant of strain of 15.8 millimeter per minute. A trace
A trace
relating
relating
strength
strength
and
and deformation
deformation
is
is
automatically
automatically
recorded on a graph
recorded
paper.
on a graph paper. Determine the stability of each specimen as the maximum load that the specimen could withstand. Apply correction to the stability values if required.
Determine the stability of each
Hi guys, my
specimen
name is
as the
Ishakim
maximum load
Ibrahim
that the
with number
specimen could
registration
withstand. Apply correction to the stability
17DK20441.
values if
Again, today
required.
I will explain about the procedure of Marshall stability test. Okay. For bulk
Read also the
mixture
deformation at
preparation,
failure
measure
and
the
report
amount
this
of
value as the
aggregate
flow in millimeter.
and filler to be used in order
Thank
to
you for
meet
your
the
time.
specification limit.
If you have
About
any questions, do not hesitate to contact us at
1,200 grams of blended
sarg.usm2011 at
aggregate sand and filler
gmail.com.
is prepared in a container to produce a Hi, my name is Ishakim Ibrahim with number registration 17DK20441. Okay, I will explain about the data and the calculation. Okay, for the provided image displays initial data and parameters relevant to a Marshall stability and flow test for bituminous mix design. The test was conducted with a mixing temperature ranging from 149 to 114 55 degrees Celsius, utilizing a VG14 grade of bitumen, and specimens were compacted at temperatures between 95 and 150 degrees Celsius, with 75 glues applied to each side. The proving ring used for stability measurements had a calibration factor of 0.307, and the flow value was measured with a dial where one division corresponded to 100 to 0.1. Furthermore, the image includes a table detailing the weight of different sizes of coarse aggregates and filler material used in bricks. This table presents the size, cumulative percent passing, percent retain, cumulative percent retain, and calculated weight of aggregate required for both a single sample and 8 samples, totaling 7,140 grams for the latter. This information regarding the test condition and aggregate compositions is essential for subsequent calculations and analysis to determine the Marshall stability and flow values of the asphalt mixture at various bitumen contents, ultimately aiding in the determination of the optimum binder content for pavement application. Okay, now we look at the table. The image displays a table titled weight of different sizes of coarse aggregate and material, which presents data related to the composition of an aggregate mixture used in a material testing process, possibly for asphalt or concrete. The table is organized into several columns, starting with size, indicating the different discrete sizes used to describe the aggregate particles, ranging from 37.5 down to 0.075, and including a pen to collect the finest material. The subsequent columns provide information on the cumulative percent passing, showing the percentage of the total aggregate weight that passes through each size, and the percent retained, indicating the percentage of aggregate weight held back by each specific sieves. Following this, the cumulative percent retained column displays the total percentage of aggregate retained on a given sieves and all larger sieves. The table also includes two columns detailing the weight of aggregate required for one sample and the weight of aggregate required for 8 samples, providing the mass in grams of each aggregate size needed for a single test specimen and a batch of 8 specimens respectively. The total weight of aggregate for one sample sums to 815 grams, and for 8 samples it totals 7,114 grams, indicating the overall quantity of aggregate used in the test setup. This detailed breakdown of aggregate sizes and widths is crucial for ensuring the correct gradation and proportions in the material being tested. Okay, now I will explain about observation table for density and voids. Okay, the table records data for 4 different specimens numbered 1 through 4. For each specimen, the table lists the bitumen content as a percentage, the height of the specimen in milliliters, the weight of the specimen in air in grams, the weight of the specimen in water in grams, the weight of the specimen in a saturated surface, dry, or in short form we call it SST, condition in grams, the calculated bulk volume in cubic centimeters, the from subtracting the weight in water from the weight in SSD and the calculated bulk density in grams per cubic centimeter obtained by dividing the weight in air by the bulk volume. The data shows a variation in bitumen content across the four specimens, ranging from 9% to 12%, which appears to correlate with slight difference in their physical dimensions and weights, ultimately influencing their calculated bulk volumes and bulk densities. To the right of the table, Figure 1 shows four cylindrical specimens, table 1, 2, 3, and 4 sitting on a grain stool, described as specimens after the 40 bath, suggesting a step in the density and voids determination process that involves water submersion. Okay, now I will explain about observation table for Marshall stability and flow value. The table presents data for four specimens, each with a varying bitumen content ranging from 9% to 12%. For each specimen, the table records the measured load in kilograms, a thickness correction factor, proving ring correction factor, which is consistently 0.307 across all specimens, the calculated corrected load in kilogram, and flow dial rate. The corrected load, representing the Marshall stability, varies across the specimens, with specimen 2 showing the high Hertz value. The flow dial reading, indicating the deformation of the specimen under load, also varies, generally increasing with higher bitumen content in this dataset. Figure 2 shows that what appear to be cylindrical bituminous specimens contained within modes, suggesting a stage in the Marshall's stability test procedure where specimens are prepared or have been tested within these modes. The data in the table, along with the visual representation of the specimens in notes, provides key information for analyzing the stability and flow characteristics of the bituminous mixture at different binder content.
And then next, for optimum bitumen content determination for B1, bitumen content corresponding to maximum density is equal to 10%. And then for B2, bitumen content corresponding to maximum stability equal to also 10%. In addition, this graph plotted between with bitumen content on x-axis. So this is the graph for bitumen content versus Marshall stability and the bitumen content versus density. And lastly, for the graph bitumen content versus flow. And for the result is optimum bitumen content equal to 10%. Marshall stability at optimum bitumen content is equal to 271.68 kilogram. And lastly, Marshall flow value at optimum bitumen content 1.9 millimeter. So for the conclusion, the Marshall stability test successfully determined the optimum bitumen content for the bituminous mix by analyzing the relationship between bitumen content, stability, and flow values. From the test result, it was observed that stability increased with bitumen content up to a certain point and then began to decreases, while flow value consistently increased. The optimum bitumen content was selected based on the peak stability value combined with acceptable flow and satisfactory volumetric properties such as a void in mineral aggregate, and a void filled with bitumen. The test confirmed that a well-balanced bitumen aggregate mix ensures adequate strength, durability, and resistance to deformation under traffic load. Therefore, the Marshall method provides a reliable and empirical approach for design bituminous pavement that can withstand expected field condition. So that's all from us.